Right now, you are somewhere on Earth. You know exactly where. Pull out your phone, tap a button, and a blue dot appears on a grid covering every road, river, and mountain on the planet. The map just knows. It always knows. But nobody ever asks the real question. How did the human mind, the same mind that spent 290,000 years wandering forests without a single reference point, learn to shrink the entire world onto a flat surface? Because that should not work. The world is round, paper is flat, and yet, roughly 2,300 years ago, a man sitting in a library in Egypt calculated the circumference of the entire Earth to within 2% of the correct answer, using nothing but shadows and a stick. He was not using satellites, he was not a god, he was using geometry. And that story, how any human got there, is not a story about technology. It is a story about how the human mind learned to see the world from a perspective it has never actually occupied, from above. Let's go back to the beginning, because the first maps were not drawn by scholars. They were not drawn on paper, they were not drawn at all. They were spoken out loud around a fire. For most of human prehistory, geography lived in memory. Your ancestors were walking encyclopedias of terrain. They knew which valley flooded in spring. They knew where the animals went in winter. They knew the landmarks, a twisted tree, a notched ridge, a dry riverbed, that marked the boundary between their territory and someone else's. Cognitive scientist Edward Hutchins at the University of California, San Diego, argued in his 1995 book Cognition in the Wild that human thinking is not just what happens inside the skull. It is distributed across bodies, tools, and environment. Your ancestors did not need maps because the landscape itself was the map. It was stored in muscle memory, in story, in song. Some of the oldest navigational traditions on Earth still work this way. The Polynesian navigators of the Pacific settled islands across 10 million square kilometers of open ocean, without any instruments at all. They memorized star paths, wave patterns, the behavior of seabirds, the color of the water. They were not reading a map, they were reading the world. But something changed when humans started trading. Once you need to tell a stranger where something is, a market, a river crossing, a mountain pass, spoken memory is not enough. You need to make the information transferable. You need to mark it down. The oldest known map in the world is not a map of a city or a coastline. It is a map of a valley. Found in 1966 by archaeologist Paolo Graziosi at a bounce cave in Spain, it is scratched into a piece of sandstone roughly 14,000 years old. It shows mountains, rivers, and what appear to be animal grazing areas. Nobody made it for decoration. Somebody made it to share information about where the food was. That is all a map is. Information about where things are, transferred from one mind to another. But from a scratching on stone to a mathematical model of the entire Earth, that is a leap that took thousands of years. And it started in a place most people associate with pyramids, not geometry: Egypt. Around 1160 BC, Egyptian scribes produced what is now called the Turin Papyrus Map. Discovered by Bernardino Drovetti in the early 19th century and now housed in Turin, Italy, it shows a gold mining region in the eastern desert. It marks mountains, roads, and a mining settlement. And crucially, it includes a scale. Somebody understood that the marks on the surface had to correspond to distances in the real world. That is the key insight. A map is not a picture of a place. It is a ratio, a controlled compression of reality. The Greeks pushed that idea further than anyone before them. Around 600 BC, a philosopher named Anaximander of Miletus produced what many historians consider the first map of the known world. He drew the Earth not as a collection of local landmarks, but as a single coherent object surrounded by ocean. His student Hecataeus revised it around 500 BC, adding coastlines and interior regions based on traveler accounts. Neither map was accurate by modern standards, but the ambition behind them was extraordinary. They were not mapping a valley, they were mapping everything. And then came the shadows. Around 240 BC, a Greek scholar named Eratosthenes became the head librarian at Alexandria, the largest repository of knowledge in the ancient world. He had read a report that in the city of Syene, modern-day Aswan, the sun at noon on the summer solstice cast no shadow. Objects were lit directly from overhead, straight down. In Alexandria, roughly 800 kilometers to the north, the same sun at the same moment cast a shadow of about 7.2 degrees. Eratosthenes did not need a satellite, he needed arithmetic. If the sun's rays are parallel, which they effectively are at Earth's scale, and the shadow in Alexandria is 7.2 degrees, then the arc between the two cities is 7.2 degrees of a full circle. A full circle is 360 degrees. Divide 360 by 7.2 and you get 50. Multiply the distance between the two cities by 50 and you get the circumference of the Earth. His answer? Roughly 39,375 kilometers. The actual circumference? 40,075 kilometers. He was off by less than 2%. He never left Alexandria. His method, recorded by Cleomedes and referenced by the geographer Strabo, is one of the most elegant pieces of reasoning in human history, and it made maps possible in a way they had never been before. Because once you know the size of the Earth, you can build a coordinate system to describe every point on its surface. That coordinate system is called latitude and longitude. Hipparchus of Nicaea proposed a grid of parallel lines crossing the Earth's surface around 150 BC. Then Claudius Ptolemy, working in Alexandria around 150 AD, extended that system into the first systematic geographic atlas, the Geographia, which mapped over 8,000 locations using coordinates. It was the conceptual framework for every map made in Europe and the Islamic world for the next 1,400 years. But there is something Ptolemy got badly wrong, and it shaped the entire history of exploration. He underestimated the size of the Earth. When Christopher Columbus proposed sailing west to reach Asia in 1492, he based his calculations partly on Ptolemy's measurements. He believed Asia was roughly 3,700 kilometers to the west of Europe. The actual distance across the Pacific is nearly 20,000 kilometers. Columbus would never have survived that voyage. He did not survive it. He found something else entirely. And that is the paradox at the heart of every map. Every map is a theory about the world. It is never the world itself. It reflects what the mapmaker knew, what they believed, and crucially, what they did not know they had wrong. The Fra Mauro map of 1450 placed paradise in the east and sea monsters in the margins. The Mercator projection of 1569 made Greenland appear the same size as Africa, when Africa is actually 14 times larger. It was designed for navigation, not proportion, but it became the standard world map taught in schools for centuries, subtly warping how an entire civilization pictured the planet. Every map you have ever looked at is an argument. It is someone's decision about what matters and what does not, what to show large and what to push to the edges, where to put the center, who to make look small. Tonight, when you open your phone and the blue dot appears, you are holding 14,000 years of human ingenuity in your palm. From a scratching on sandstone in a Spanish cave to a military satellite 20,000 kilometers overhead, the mission has never changed. To answer one of the oldest questions your species has ever asked, where am I? The remarkable thing is not that we finally found an answer. The remarkable thing is that a creature designed to walk through forests learned to see the world from space, using nothing but curiosity, geometry, and a stick casting a shadow on a summer afternoon. You are somewhere on Earth right now, and you know exactly where. That is not an accident. That is 14,000 years of humans refusing to be lost.